So we have just completed the distance and displacement part of, so, okay, Tanisha, I think have you revised the last class topic, distance and displacement? Okay, that's good. So in this class, we are going to discuss about the uniform and non-uniform motion, what it is basically. So in the coming topics, we'll be discussing very frequently what is uniform and what is non-uniform. And in this chapter, everyone, will be discussing only uniform motion, because in ninth standard, only uniform motion is there, right? Apart from it, non-uniform motion you will study in the you can say the 11th standard in very detail. Right now, you will study only the uniform motion. Is that clear to both of you?
Yes.
That's great. So now let's talk it about, okay, so what is uniform motion basically? So let me draw a figure. Okay, so instead of that, suppose that so as you can see, everyone, this is point A. Okay, so instead of making it, just let me color it dark blue. Make it dark. Okay. So this is okay. So this is A. This is B. Okay. This is B, and this is C. Okay. So suppose that. Okay. So first distance that you have covered is 100 km. Okay, in 1 hour. Okay. Another distance that I have also covered is also 100 km in the 1 hour. Okay. Clear both of you? So you can see that when the distance is covering equally in equal interval of time, such type of motion is called the uniform motion. Uniform means there is a similar pattern that you will be seeing throughout the journey. Suppose that everyone, you must have seen that why does the school wearing is called uniform? The clothes that you wear to go to the school, why is it called uniform? To make all the students look equally, right? So that you look very similar to each other. There's a similar pattern that you have basically. Suppose that for girls it's suit salwar in India, and for boys it's a shirt and pant and trousers. You can say, right, everyone? So so that the boys looks very similar to each other and the girls look very similar to each other, isn't so? So that's why it's called uniform. Uniform means to make the similarity. Clear to both of you, everyone? Yes or no? Please do let me know.
Yes, sir. Yes.
Okay. So that's what uniform motion is. When the body is when the body covers the equal distances in equal amount of time, that is called a uniform motion. Okay. Uniform motion. Okay. So let's write down the this a body has covered, so just a second. Okay. Has a uniform motion if it travels equal distances in equal interval of time. Okay. And one more thing is that doesn't matter how small the interval is. Interval means that it could be 10-second interval. The basically our overall period, you can say 10 second, 1 second, 2 second. It depends completely on the you can say scenarios. So in usual, we take an interval of 1 second in usually. Okay. So right now we are not mentioning any specific interval over here. So okay. So overall interval of time. Is that clear to both of you?
Yes, sir.
Yes, sir.
That's great. That's great. Okay. So an example would be example of the uniform motion could be, you must have seen that we regularly observe that after 12 hours there is a shift in day and night. Yes or no? By the by the evening in the basically by the 6 in the evening, you will see that the sun will sunset. But in the morning around 6, it will sunrise. Obviously, there will be a change in weather. So sometimes it might be 13 and 14 hours. I'm just taking a general case. Okay. So after every 12 hours, you will see that there is a change in day and night. That means it is a uniform motion because it's after specific 12 hours, there will be a shift. And another example could be, you must have observed that when the year is completed, every year we complete the year within 365 days, except leap year. Just that's a rare case, so do not assume that. So we are saying that in 365 days, we basically complete a year. So after every 365 days, we get into the new year. Yes or no? So these are the examples that you can use to relate the uniform motion in our day-to-day life. Clear, so everyone? Okay.
Yes.
So examples. Examples could be revolution of Earth, Earth and rotation of Earth, and ticking of a clock. So after every 60 seconds, the clock, second hand clock will come back to the 12th position, the 12th number. So that's okay. Yes or no? So that's also the uniform motion, rotation of Earth, or you can say rotation of Earth. Is that clear to both of you? Please do let me know, Bachcho.
Yes, sir.
That's great. Now let's talk about the second thing, non-uniform motion. So non-uniform motion is opposite of the uniform motion. That means, everyone, suppose that in the initial case, you are covering 100 kilometer in 1 hour. After some time, basically after covering 100 kilometer, you got stuck in the jam. So will you be able to cover 100 kilometer in the next hour?
No, sir.
No, no, definitely not. So in that case, it would be 50, 60, whatever it should not be equals to 100. So apart from 100, it could be any number. It could be 120 as well. It could be greater than 100 as well. It could be less than 100 as well. But it should not be equal to 100 to make it a non-uniform motion. Okay? So real world examples are very good examples for the non-uniform motion. Suppose that you are traveling. Okay, so sometimes bus will stop, sometimes bus will basically accelerate, sometimes it will basically go with a uniform speed. So in every scenario, you will not be able to cover the same distances in the same interval. Like in 1 hour, it will be different. It could be 10 meter. In the next hour, it could be 30 meter. It could be different. Okay, so that's what the non-uniform motion is. Is that clear to both of you? Please do let me know.
Yes, sir.
Yes, sir.
Check. Let me copy it. So just replace it with 80 kilometer, you can say. Okay, 80 kilometer. So that's what non-uniform motion is. When a body is covering unequal amounts in the equal interval, that is called non-uniform motion. Okay. Uniform motion. Existence equal Is that clear to both of you? Please do let me know.
Yes, sir.
Yes.
Yes. Okay, so real world examples of the could be. Could you please give me an example? Please tell me an example that. Could you please repeat, Javerium?
Pausing a video.
Pausing a video. Pausing a video. No, that's not the appropriate, you can say, because it's not relevant. We're talking about the motion of a body. Any other? It could be any other example.
Playing tennis ball.
Could you please repeat?
Playing tennis ball.
Playing tennis ball. That's an example. Yeah, because it depends how hard you will basically hit the ball. Okay. So example could be car is moving on a track, circular track, racing track. So it will increase or decrease continuously. Okay. Okay. Running athlete. So when the athlete is running, it's not certain that how long will it go. Okay. Obviously, after some time, the speed will decrease of the athlete. Yes or no, everyone? Okay. So this is the basics of the uniform and non-uniform motion. Please do let me know, everyone, is that clear to you or not?
Yes, sir.
Yes, sir.
Okay. Another example could be when you drop a ball after some height, you will see that the ball will start falling downwards with a increasing speed. Yes or no? The speed will increase continuously when you drop a ball. So that is also an example, falling a ball. That is also an example of it. Clear to both of you?
Sir.
Yes. Anything, Javed, that you'd like to ask? Are you saying something?
No, sir.
Okay. And what about you, Tanisha? Is that clear to both you?
Yes, sir, it is clear.
Sure, that's good. Check, that's good. Please note it down and let me know once done. Done, everyone?
No, sir.
Check it fast.
Excuse me, sir. Done.
Okay, okay, Javed, that's good. Okay, now let's talk about the next part. That is the next topic of your chapter. That is your speed and velocity. Okay. So it is one of the important topic that you have to study in this standard. That is speed and velocity, and it tells you that how. Okay, so basically everything, because we are talking about the motion. In generally, we'll be talking about motion. So you should know that with what's like how fast your body is moving, right? So that you can understand whether it's that much fast or not. Yes or no, everyone?
Yes, sir.
That's great. Okay. Let's just get that's, okay. Okay, now let's talk about what is speed basically. It's another pen. If I have like this, let's take it this way. Speed. first thing about speed is it tells you that how much distance you have traveled in 1 second. Okay. Speed of a moving body is basically can be defined as the distance traveled by a body in unit time. In 1 second, whatever the distance you have covered will be called as speed. Is that clear?
Yes, sir.
The distance traveled by a body per unit time is called speed. Okay. Next thing about speed is everyone that it is a scalar quantity. That means it's not gonna depend on the direction. It will only change if you change the direction of it. So if you change the magnitude of it. That means suppose 13 meter per second and 14 meter per second. So it only depends on the magnitude. If you increase it, the speed will increase. Clear to both of you?
Yes.
No, sir.
No, not clear? Check it. So that means suppose that Tanisha, this is 13 meter per second. Now, if you are changing the speed, that means you are increasing it. Suppose that it is 17 meter per second. So if you change the magnitude, this number is called magnitude basically. Okay. If you change this number, the speed will change. That means we can say that speed has been changed. So it depends only on the number, not on the direction, because speed is not involved. It does not involve the direction. It doesn't matter wherever you are going. The only thing that will matter will be the number. If you are changing this number, that means speed is changing. Is that clear now?
Yes, sir.
Check. Now, scalar quantity. Okay. Next thing would be everyone. Okay. Next thing would be speed, because we have talked about speed is the ratio of distance and time, right? That means speed of a moving body will always be greater than zero, because distance of a moving body will always be greater than zero. It will not be equals to zero if a body is moving, or it will not be less than zero if the body is moving. Yes or no, Javeri and Tanisha? According to the
Yes, sir.
definition of distance. So that means speed of a moving body will always be greater than zero. It's always positive, you can say. Okay. Next thing of the basically based on the speed is the SI unit. The international unit that we see is meter per second. Because distance is meter and time is in seconds. Okay? Clear to both of you?
Yes, sir.
Any doubt?
No, sir.
Good. So, and the formula of the speed is equals to distance here. Okay. So this is what speed is basically. Okay, we also measure the speed in kilometer per hour, but that's a different unit. But we are talking about the SI unit, so it will be meter per second only. And now let's talk about the next thing. Speed is okay. So now let's do a question based on the speed, very basic question. So let's do one thing. Let's complete the velocity part first. Okay. After that, we'll do a combined question. Second thing is velocity. Now let's talk about velocity. So velocity is the vector quantity that adds the direction into the speed. That means in simple words, velocity is the ratio of displacement over time. Just like we had displacement and distance, vector and scalar, similar to each other, we also have the velocity and speed. So if you add the direction to the speed, that quantity will become velocity. Clear? So velocity can be written in two ways. Velocity can be written as the rate of change of position is called velocity. Next is the ratio of displacement per unit time is also called velocity. So both of the definitions are right. Okay, and you can use any of them. Okay? So you can say that the rate of position of moving body in a given direction is called velocity. Okay? Second would be the velocity is a vector quantity. That means if you it will involve the magnitude as well as direction. Because scalar and vector is not a part of your syllabus, so that's why we are not going that much deep into the scalar and vector. Otherwise, I would have gone it. But just remember that vector quantities depends on direction as well as magnitude, and scalar quantities only depends on the magnitude. Okay. Next is everyone, as I've told you, it's a vector quantity. So velocity of a moving body can be zero, can be negative, and can be positive, similar to the displacement. Because in displacement, we can have zero displacement, we can have positive displacement, we can have negative displacement. Yes, everyone? And same as well in the velocity, we can have zero velocity, when we can have, you can say the negative velocity, we can have the positive velocity, even if the body is moving. Even if the body is moving. But in speed case, speed will always be greater than zero. Yes or no, everyone? Did you get my words?
Yes, sir.
Yes, sir.
Chicken? Clear, both of you?
Yes, sir.
Check it. Next is similar to the speed, the unit is same. Meter per second. Right. Okay, next thing about display velocity is just let me write down the formula how to represent the velocity. So velocity is written as displacement over time. Just please note down the things that I've written over here. Just give me a second. Then everyone,
Yes, sir.
Yes.
check it. Now let's talk about the velocity effect basically that the thing that affects the velocity. Yeah, the second part will be okay. So velocity can be changed in two ways, everyone. So the first thing in which that can change would be if you change the magnitude. Suppose that if 17, I've told you that velocity is a combination of magnitude. Just let me write it. Magnitude plus direction. Yes or no, everyone? That means if any of the thing changes, velocity will be having some effect. That means velocity will change. Suppose that magnitude means if I'm changing the velocity from 13 meter per second to 20 meter per second. Clear? That means I'm changing the magnitude, the quantity of the, basically quantity of the speed or the velocity, right? So that's the first thing that you can, that's how you can change the velocity of a body. Second case is 13 meter per second will remain as it is, same, but you have changed the direction. First it was north, now it's south. That means if you change any of the quantity, either magnitude or direction, velocity will change. Clear to you, Javeri and Tanisha? So if any of the thing changes from the velocity perspective, the velocity will change. Because it's a vector quantity, so it depends on the direction as well. Clear, both
No,
of you?
sir, I didn't understand.
See this thing. Suppose that a body is moving in this direction 20 meter per second east. Okay. Now, in what we have done is basically direction is remain same, but we have changed the velocity to 25 meter per second. So will the velocity get changed or not if you change the magnitude?
It will.
It will. That's right. Now let's take another example. So body was going 20 meter east per second, but after some time, the velocity will remain same, but you have changed the direction, that is west. That is 20 meter per second. In that case as well, velocity is changing because the direction is being changed. Okay?
Yes, sir.
So that's what I'm
Yes, sir.
saying. So the velocity depends on magnitude as well as direction. So if you change any of the things, the velocity will change. Let me raise it. Check it. Okay. First would be by changing the speed. That means magnitude is nothing but the speed, no? If you add direction to the speed, it will become velocity. That means if you change the speed, the velocity will change. Or second would be by keeping speed constant, but changing the direction. This is direction short form. So please do let me know, everyone, is that clear to you or not?
Yes, sir.
Yes.
Clear.
Yeah. Please note it down. So now after that, let's talk about the one thing. So this was velocity and speed. Done, everyone?
Yes, sir.
No, sir.
Check. Okay, Tanisha, no worries. Please note it down.
Yes, sir. Done.
Check. Next thing that we have to discuss is uniform speed and uniform velocity. Check it. So in simple words, uniform speed is that speed basically in which body travels equal distances. So that means body is covering equal distance in equal amount of time. Because distance over time is speed. So that's why when the body is covering equal distances in equal amount of time, that is called uniform speed. And if a body is covering equal distances in equal amount of time along with the direction, same direction, that is called uniform velocity. Is that clear to both of you?
Yes.
Yes,
So
sir.
let me write down. Yeah, let me write down the speed, uniform velocity and speed. Uniform speed. If we talk about the uniform velocity, it travels.
So what is that word after uniform velocity?
If it travels in a specified direction, in a straight line. And so what does it mean? It means that it's not changing anything. It's covering the same amount of distance in equal time, and it's going in the same direction.